So that was something about variables. Now let's talk about how to describe variables. So you got some measurements, you got some values, how to describe them. We know that you cannot say how much of chloride in water in a certain lake, because every time you take a small portion of this water or in the lake, you will get a different number. So can we do something with that? How to describe random numbers? Well, first of all, we will learn non-parametric approach. And the idea of actually both non-parametric and parametric approach is following. Well, first of all, we know that all individual values, they vary randomly. Okay, so they are not predetermined, they are not determined, they are random. Then we need to describe behavior of these values. And since they vary, the easiest way will be to describe a center, around what they vary. Then to describe a spread, how far they vary from the center, how far they can go from each other. And then sometimes it's a good idea to calculate some statistics, some measurements of what's going on in different parts of this interval they vary in. Okay. So what we need to do is the following. We need to calculate some numbers that will tell us where the center is, how big the spread is, and what's going on in different parts of the interval. That will be the description of random variables. Okay. And that's what actually descriptive statistics does. It allows you to calculate different statistics, which gives you an idea where the center is, how big the spread is, and so on. And what you see here are the most important non-parametric statistics. First of all, it's of course the smallest and the largest values, the difference between the smallest and the largest values, median, quantiles, quartiles, percentiles, all that kind of things. So let's go through these statistics. Most of the non-parametric methods, they are based on rank. Rank, it's a position of a number in a non-decreasing sequence. So first of all, you have to sort your values. You have the smallest one, the next smallest, up to the largest one. And then you can define a rank. It's a position of every value in this sorted sequence. Then if you know the rank, you can easily calculate several statistics. First of all, the value is rank 1. The first value in this sequence, it's the smallest value, so it's a mean. The last value, the value is the largest rank, it's a largest value, it's max. Then the middle value, so the value in the middle of this sequence is called median. And that could be a good approximation of your center. So it can be a good measurement of the center of the values. Okay. Then we have a problem because sometimes you have a certain value in the middle, sometimes you don't. Let me give you an example. Let's say you have 5 values, 1, 2, 3, 4, 5. In this case, of course, the median is this one, right? So you have a certain value which is a median because 2 values are above that and 2 values are below that. So you have rank 1, 2, 1, 2, 3, 4, and 5. So that's easy. But what if you have, for example, 6 values? In this case, you don't have a particular value in the middle because the middle is here, right? So you have 3 values above and 3 values below. So in this case, you simply take this, take a sum and divide it to 2. So you calculate average of these 2 values. So in this case, the median will be an average of these 2 values. Okay. So these are the simplest statistics. And let me show you an example. Let's say we have a height of 10 persons. So we have a sample and it consists of 10 individuals, 10 persons. And these are the height values. Okay. First of all, we have to rank. We have to sort the values. So these are sorted values. So every value has its rank. And now we can easily find that the smallest height we have is 162 centimeters. The largest height is 188 centimeters. The range, which is the difference between the smallest and the largest, is 26 centimeters. So it gives us an idea of the spread, how far the values can go from each other. Then finally, median, because we have even amount of values, we have to take the 2 in the middle and then take the average of these 2. So that's the median. So the median height is 176.5. And then you can represent the values and the statistics using a simplest plot possible, which is called a dot plot. In dot plot, you have only one axis, which is x-axis here. And then you can show the values as points. So for example, this is the smallest value, this is the largest value, and so on. And then you can see this is the median. Then you can see that the values are distributed more or less evenly inside between the maximum and the minimum value. Now you can calculate a statistic for every value. And this statistics is called a quantile, or sometimes it's called percentile. We will discuss the difference soon. There are several ways to calculate a sample quantile. One of the ways is this one. You can see the formula here. So the quantile or percentile is a rank of value minus 1 divided to the number of values. For example, let's take 162. Why we have quantile 0? Because the rank is 1, so I is 1, okay? And the total amount of values is 10. So the quantile or percentile for 162, it's y minus 1 divided to n, which is 1 minus 1 divided to 10, which is 0, right? And the meaning of this is 0% of the values are smaller than 162. 10% of the values are smaller than 164. 20% of the values are smaller than 168, and so on. So percentile tells you a percent of the values smaller than the given. Okay. There is another way to calculate percentile, assuming that this is just a sample, it's not a population. There is a chance that you will have some values below given, right? So in this case, it's probably a good idea to center your percentiles. So instead of minus 1, we subtract 0.5. What it changes? It changes the following. The 162 now have 5%. It's a fifth percentile, so it means that we expect that 5% of the values will be below 162. Okay. How do we calculate it? Well, 162 has a rank 1, so we take 1 minus 0.5 divided to 10, which is 0.05, or it's a 5%, right? Now think, what happened is 162 is also the smallest value, but n is equal to 100, so you have a big sample. So in this case, the percentile, the amount of values, expected values below the given, will be 0.005 or 0.5%, right? Which is closer to what we see in our sample, right? So the bigger sample is the closer it to the population, and for the percentiles will be smaller for the smallest value. Okay. For the population, of course, the percent of the values below the given, below the smallest is 0. Okay. So that's another way to calculate percentiles. And why I like this way is that, for example, median, it's a 50th percentile, right? Because 50% of the values should be below median and 50% of the values should be above median. And you can think that median is exactly between the 176 and 177, right? So we have percentiles in accordance to the median definition in this case. In reality, it doesn't matter which formula to use, because the difference will be quite small, especially if your sample size is large. And you can also use the individual percentiles to calculate something unknown. For example, you know that 162 is the 5th percentile and 168 is 95th percentile. What is the 20th percentile? Well, apparently it should be somewhere in between, right? You can think of these two. So you have 15th percentile, 164, it's 15th percentile, and then 168, it's 25th percentile. So apparently the 20th percentile will be equally distanced from these two. So you can take it just an average, so it will be 166. So 166 is the 20th percentile for our sample. So it means that you expect that 20% of the values will be below 166. Then quantile. Quantile is when you take all your values and split to equal portions. For example, if you want to split your values into 2 portions, you have to take 50% of the values on the one side and 50% of the values on the other side, right? And that's median that does it. So you have one value that split all your values into 2, okay? So every time you want to split your values into n groups, you need n minus 1 points, and these points are called quantiles. So in this way, percentiles are also quantiles, because percentiles allow you to split your values into 100 equal portions, right? So now we know several quantiles. For example, median, it's a quantile that allows you to split your values into 2 portions. Then we also have quartiles, which these are 3 values, the first, the second, and third quartile, that split all your data into 4 equal portions. Then we have percentiles, we have also deciles, and many others.